Welcome to Get Your FRQ On. This question is from 2003, Test B, and it is question 6. It is not calculator active. In the question stem, we are given a differential equation of the form f prime of x equals a function, and an initial condition such that f of 3 equals 25. In part A of the question, we are asked to find the second derivative of f at 3. So to do this, the second derivative, we're going to take the derivative of the first derivative, which is going to be the derivative of x times the square root of f of x. And if we apply the product and chain rules correctly, we get x times f prime of x over 2 times the square root of f of x plus the square root of f of x. Then, after substituting 3 in for x, we get 3 times f prime of 3 over 2 times the square root of f of 3 plus the square root of f of 3. Doing the necessary substitution into that expression, we get 3 times 15 tenths plus 5, which when you simplify it gives us 9.5. In part B of this question, we are asked to find the particular solution y equals f of x if dy dx is equal to x times the square root of y, and we use the initial condition that f of 3 equals 25. For this question, as with pretty much any question where you have to solve a differential equation in a free response, the expectation is that you're going to use separation of variables. In fact, not using separation of variables could prevent you from earning any points on that particular part of the free response question. So we're going to set up our separation of variables. Dy dx equals x square root y implies that dy over the square root of y is equal to x dx. And then we just take the antiderivative of both sides. Taking the antiderivative of both sides, we get 2 times the square root of y is 1/2 x squared plus a constant, which implies that the square root of y is 1/4 of x squared plus a constant. Then, using the initial condition that f of 3 is equal to 25 to solve for the c value, the square root of y equals 1/4 of x squared plus c. Substituting in 25 for y and 3 in for x, we get 5 equals 9/4 plus c. Subtracting 9/4 from both sides, we get c equals 11/4. The expectation here is you're not just going to solve for c, you're actually going to rewrite the function y equals f of x using the value of c that you just found. So the particular solution here would be y equals, in parentheses, 1/4 of x squared plus 11/4, and then that squared.